running everything securely should be your absolute and number one priority, to the point where if you can't secure it, you should probably turn it off. So just to go through the difference. So security authentication, we're talking about a wide range of practices and technologies that's designed to protect your data, applications, and your infrastructure. They're two separate areas, though. Whilst they get put together, they are across two different areas. So security is really involving safeguarding of those assets from unauthorized users, from different threats. And you're talking about things like firewalls, intrusion protection, and encryption. Whereas when we're talking about authentication, we're focusing on your user identities. So if you use AWS or GCP, things like IAM, and ensuring that they have the correct access rights. So we're talking about the principle of least privilege here, which is where you make sure that your users and your applications have only the very specific authentication and access that they allowed to do their job, and you never give more privileges than are required. Also talking about things such as multi-factor authentication, which is really important. It adds the extra layer of protection so that if you do have a password lying around, that can't actually be used without another device. And it's very important for these two areas to be split because of just how complex and diverse the multi-cloud environments are. If you try to have exactly the same strategy and use the same commands, the same setup across both of your different cloud environments, you're going to end up with problems because they often use different security protocols and have different standards. And you end up having to try to communicate. So you're often going to be sending data back and forth as well between these different multi-cloud environments. And so you need to be able to have them to talk to one another. And the moment that you have data being sent between the two different cloud environments, as I was saying, it's likely that data is going to be sent via public internet, encrypted or not, but that's suddenly going to be an extra risk. And when we're talking about compliance and governance a little bit later, you can see why that is such a big risk for some of our customers. So one of the big areas that you'll find is that when you have a multi-cloud, you're actually going to have what's known as like a larger surface area of attack. So when you've just got one cloud vendor, say such as like GCP, you can very tightly control how people access into that area. So you can control that on, say, IP addresses, and you can only, effectively, you can only allow this perhaps your own company's like internal IP addresses, which will basically restrict anybody not coming from your corporate network. You can use things such as VPNs or connections or direct connect into AWS to help secure that. But when you need to open things up across multi-cloud, you also now need to have connections going between your different cloud vendors as well. And that's actually much harder to start to lock down. For starters, you can't now really lock it down on IP addresses because the IP ranges being used by these cloud vendors change all the time. So it's extremely difficult to start looking it down. You have to start looking at other areas. And by doing that, you're increasing the number of places that a hacker can try to gain access. You're also likely to end up using things like access keys, which you're probably using for your developers and people using CLI access is probably using access keys already. But you're probably going to end up using those access keys to send traffic to different cloud environments to do cross-cloud authentication. And again, that can be a really big area of risk because as you're connecting in and you're using those keys are effectively having to be stored somewhere. And we've come across a customer who quite recently was using access keys, and they were storing those access keys on a web server. And in the back end, the access keys that they had granted on the web server, unfortunately, had permissions to create EC2 instances within AWS. That access key then was stored on a web server's configuration file in plain text, and a hacker got hold of it. So this customer was billing around $500 a day of compute instance, fairly small customer. The hack happened late Friday evening when everyone had gone home and the customer didn't notice it. They didn't have a lot of things set up, didn't have very much automation, they didn't have very many CloudWatch alarms. They did get an alert from us telling them that their cloud spend had gone very high, but they ignored it and didn't respond until the Monday morning. On the Monday morning, AWS had already had suspended their account because AWS had detected it appeared to have been breached. And the hackers had created several thousand EC2 instances, all in every different region going, which made it really difficult to clear up. It's pretty likely they were mining Bitcoins because they were high GPU instances, which tend to be used by Bitcoin miners. And they got a bill of $56,000 in one weekend. And that was really just down to a mixture of problems that they had. One was was storing access keys in plain text on a web server, but also it's the fact that access key had such high amounts of privileges. The web server did not need to be connected into a back-end user that had permissions to create an EC2 instance. There was no need for that role to have been granted. So there were two places that they could have protected from that. And when you're using things in multi-cloud and you've got keys saved in GCP or things saved within AWS, and you're trying to communicate between these two, the chances of something like that happening, of additional roles being granted because you hit a problem, how many times has that happened? Oh, just give them admin for 5 minutes so they can fix the problem. And then how many times have you probably forgotten to revoke those admin permissions afterwards? Trying to do that again across multi-cloud where it's very difficult to see how those privileges are hanging together. It's quite hard sometimes to map users, say, in Azure to a user in AWS and to understand the flow of roles and inherit. You can inherit roles, and that can get extremely complicated. And it's extremely easy to make what is really a really simple mistake, and in doing so, open up the whole of your account to, huge amounts of hacking. So what can you do really to try to avoid this? It's really important that you implement like a unified security framework. Alex has talked about it several times around try to automate everything. Humans make mistakes, we make typos, we do things without thought. If you have everything deployed via Terraform, then you can really start to lock that down and control it. It's far less likely that somebody will inadvertently create the wrong role or leave a security group or a database open to the world. If you're using Terraform that blocks that kind of configuration, they'd have to actively override it to make that kind of a change. You want to be investing strongly in things like multi-factor authentication and role-based controls. That's a really simple way. Using multi-factor authentication wherever you can for your users. You can't obviously use that for an application, but for your users, it just removes the chances of their account being breached. It near enough makes it impossible for someone to gain unauthorized access to one of your developers' accounts or one of your user accounts. You want to be looking at things like advanced threat detection. Within AWS, for example, you've got GuardDuty, which is effectively a machine learning powered detection tool. It monitors your account. It knows the kind of things that you do as a company and that you do within your AWS account. And if it sees someone doing something that seems out of character for your company and for how you use AWS, it will then generate an alert, and then you can go and take action. You also want to be doing really regular security audits and making sure that you haven't had authentication and access creep. You haven't just gone and granted somebody root permissions to fix a problem and then forgotten to revoke it.